that eutectic diagram is a diagram in which a eutectic point will be there, where when we cool, when we reduce the temperature, the liquid suddenly changes into two solids rather than changing from liquid to liquid plus solid and then to solid. That point is called a eutectic point. That reaction of changing a liquid into directly two solids is known as a eutectic reaction. It happens only at a special composition of the alloy and only at a special temperature, right? So you have understood this. Now, what is there in the diagram that we have not talked about? Not talked about. You see all these circles and the shades inside the circles. So this is now the fourth question. You see, whenever we give you a phase diagram, what is the first question after giving you the phase diagram? You see, we initially give you a composition and give you a temperature. The first question is, what are the phases present? Second question is, what is the composition of the phases? Third question is, what is the mass fraction of the phases using lever rule? Fourth question, can you draw a simple diagram showing the structure of the phases? So let us do it. Now when we are at point A, how many phases do we have? Only liquid. So you draw a circle, and here they are showing a color. You can draw a blank circle with no color and write liquid inside, L or 100% liquid. That is it, right? When you go to point B, what happens? Very small amount of the liquid has changed into the solid alpha. So you draw the circle, the rest is liquid, but you show a small pieces and you say that this is the alpha and you say that the rest is liquid. Of course, you can draw a tie line here. You can draw a tie line and you can find the composition of the liquid and you can find the composition of the solid. So here you find 76% tin liquid and 24, but we don't want to do that, right? We don't want to find those things. Sorry, this is the mass fraction. This is the mass fraction. 76% liquid, 24% solid. But we are not talking of that. Only draw the circle and some small dots. Those small dots are alpha, the rest is liquid. Once you go to beta, those dots have become larger, right? Because this was alpha, so all of that has become larger. So you still show that this is alpha and the rest is liquid. When you go, right? Similarly, when you go to D, you have made this even more large and so on. Once you touch, it is very critical. You see, whatever diagram you have at point D will remain, right? These big pieces of alpha inside are there. Whatever liquid is there will change to alpha plus beta. So they are drawing dash line, so that wherever there was liquid, you draw some dash. So that is it, right? So you draw some dash. So now for point E or any point below, you have these alpha inside, and this dash line is alpha plus beta. So this is very critical that once you do this in a eutectic alloy, then there will be some alpha which is separate and there will be some alpha which is inside this alpha plus beta. Inside this alpha plus beta. So how do we say this alpha and that alpha? There is a term which you have seen. Which term is there which we have not told you about? Take 5 seconds, 10 seconds and tell me one word, only one word, which you don't know on this diagram. Very good. You have found. This word is pro-eutectic. 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 You see, we are cooling. So first we are here and then we go down. So this is the start, this is the end. This is the eutectic line. Eutectic line. When you are cooling, all this is before the eutectic line. So pro-eutectic, below eutectic. And this is eutectic, and after that it remains eutectic. You understand? That this is the eutectic temperature. Because we are cooling, so we are at this temperature first and this temperature and then this temperature. So any temperature above the eutectic line is called a pro-eutectic condition. So whatever alpha we have here or here or here is pro-eutectic alpha. Alpha that is formed above the eutectic temperature. If the eutectic temperature is 183 Celsius, then at 200, 250, whatever solid is formed, that solid is pro-eutectic solid alpha. And once we hit this temperature, 183, then whatever remaining liquid was there is converted into alpha plus beta, but this is now eutectic alpha and eutectic beta. So what solid formed earlier, this is pro-eutectic alpha and dash 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 line eutectic alpha and eutectic beta, right? So this is it. So you see, this is hopefully, right? I don't know if you are enjoying it, but at least you are learning a lot. There is one diagram which we have not done yet. What is that diagram? You know, right? The diagram at the eutectic point, right? So if we give you the eutectic composition 61.9% and then say, okay, when we cool, what will happen? So here we will have only liquid, but there will be no liquid plus solid. Liquid, liquid, liquid. So it always remains this, right? Whether we are here or here or here. Suddenly, as we touch this, what happens? The complete eutectic reaction takes place. All the liquid changes into eutectic alpha and beta. No pro-eutectic. No pro. So there is no small diagrams like this. All the liquid suddenly changes into eutectic. So you can draw dash 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 all the way, or you can divide it into a few pieces because grains are still formed, right? It is grains. So you can draw a few grains, and then in those grains you can draw dash 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 dash. So it is eutectic alpha and eutectic beta everywhere, everywhere, everywhere. This is alpha plus beta, right? Liquid has changed into alpha plus beta, but everywhere, here or here or here or here, anywhere inside, it is eutectic alpha and eutectic beta, right? So this is a great new thing that you have learned, that if you have a binary isomorphous diagram, then what happens? Okay, let us proceed. Of course, if you are doing this lecture, then you can pause at any time, take a break and come back to the lecture, right? I will continue.